It is now finally time for 3D Printer Fix-Up Part 2. Hey everyone, Chris here, and it is time to finally get back to the 3D Printer Fix-Up, where we try to bring a little life back into my original 3D printer kit, the Geeetech Pro B. And it has taken me a while to get to Part 2 of this series, and there's a big reason for that. I was overthinking this whole thing. So when I started on this project, it was my intention to rework a lot of the parts on this printer and try to make it better as a whole. But after I went through lots of different iterations of parts and fan ducts and sensor mounts, I got to looking around on the internet and realized the community has already done a pretty good job on this printer because it has been around a while. So I decided to take a step back and not try to reinvent the wheel. And the first thing I do when there's a problem on a printer is usually print a Benchy and take a look. And we did that in video 1 of this series, so you might want to go check that out now before continuing here. But I took a look at the Benchy, decided what we needed to fix first without spending a lot of additional cash on this printer, because it was only $250 when I bought it several years ago. So there's no need to add to this investment. We can make a lot of improvements just with a few printed parts and a few little add-ons here and there. So that's where we're going to start today. We're going to take a look at the Benchy, see what I've decided to fix first, and hopefully make a lot of progress in this video and improve the print quality greatly. So let's get into it and just see what I've decided to tackle first. So let's just start here with our friend the Benchy where we left off in the last video. There are a lot of things here that tell me that need improvement. The biggest one that jumps out is part cooling. We're definitely going to fix that. You also notice there is quite a bit of ringing. We have a bit of blobbing in places. And definitely some signs of Z-wobble. It's hard to tell in this video, but you can also see some candy striping. And we can fix that on this board, no problems. So to fix our part cooling issues, I did mock up this part. It is not complete yet. I didn't even take the supports off of it because I have a little bit more tweaking to do. But pretty much it is a version of the Railcore fan duct that I've remade to fit this printer. So that's what we're going to do here. This is a pretty nice design, and we're going to be able to fit it behind the Mark 8 extruder housing, and it should be out of the way. And looking at our Extruder Hot End assembly, it definitely needs some help as well. So we're going to pull this apart, rebuild it, take a look at a few things that might need to be tweaked or adjusted, and just give it a once over. Also here in the front, we have these mount holes. We are going to use those for a reworked mount for our Bltouch. It shouldn't make the print quality any different, but it will definitely make it easier to use. Not looking to change the extruder or the hot end out yet, because again, I don't want to spend a lot of cash as of now. We can still make this whole thing work. And probably the biggest modification that we're going to make here that does actually cost a little bit of money is we're going to replace the Z motors with integrated lead screw motors. And that's always been the biggest weakness of this kit. The kit originally came with these threaded rods instead of lead screws, and they were bent out of the box. I should have never captured them up here with the bearing like I did, so we're going to change that up. But I did have a printed part here where the X could kind of hover on top of these instead of being attached to the lead screw, but that also creates a set of issues, but it does get rid of the Z-wobble. So putting in the integrated lead screw motors, allowing me to rework both of these sides, is going to be a huge improvement. So we'll step through that. Those motors cost around $15.50 a piece US from AliExpress, but they're definitely worth it. We'll also do a little bit of cleanup, like finding a new home for this LCD screen. Not sure what we're going to do about the filament runout sensor yet. Probably need to make another housing and get that cleaned up. But just an overall cleanup, getting things tidy, and I'm sure we'll have a better print. And just with those few tweaks right there, I am confident we will see a lot higher print quality. We will have to tweak a few things along the way, but we'll walk through all that step by step, and I'm sure this will be more than enough for this one video. But let's get started by taking a look at the Extruder Hot End Setup and see what's inside there, what might be the weaknesses, and how we can try to improve and just get things back to working order. So now let's take a look at just how this thing breaks down. We're going to take it apart. We'll start by taking the fan off the heatsink. It just has 2 screws that go through the fan, the heatsink, and the extruder arm into the motor to hold it all together. Heatsink just sits on there. And then you have your extruder arm. This screw goes all the way into the motor. Then that'll come off. Careful with that spring. And then you have the motor plate and your brass extruder gear. We'll take out this screw, and then we can remove the motor. Then we're left with the mount that actually goes on the X carriage. We can take that off with these two down here. And then we have the heat block, the barrel, as I like to call it, this heat sink type plate for mounting, and then the whole thing goes through into this motor bracket. You can see the barrel actually screws all the way into there. So from the bottom, let's remove this screw. And then we can spin off our heat block. You might have to heat this up to break it loose depending on how gummed up your nozzle or your barrel might be. Then we'll take off these retaining nuts. These nuts are actually the only thing keeping it from oozing out the top of that block, and it does just an okay job. And we can take off that top retaining nut. And with that loose, this whole barrel just backs out. You can see it's actually threaded into the motor mount. You can just clean the slag off of this a bit with a brush. And now that we have it apart, let's focus on our barrel for a little bit, because that's pretty important to making this whole thing work. Now the barrel that comes on the Geeetech, this one right here, it is PTFE lined. And then it does have just a little bit of an inset on the other end before it goes down to that liner. There's a metal lip inside there. And it's also important to note that these that come from Geeetech are around 38 millimeters long. A lot of the other ones are shorter than these. It's very common to see a 30, which you could probably make work. But there's also a 50 out there, which are probably way too long for this application. So if you're buying a replacement one of these, be careful on which one you're going to get. And one thing, at least on these older Geeetech printers using this type of barrel, that Geeetech has actually done us a favor on, is they used PTFE tube that was 2 in the center and 4 on the outer diameter. A lot of companies use a really small PTFE tube for their liner. So these will just come out. And you can see just how burned that is from being in there so long. They can be pretty tough to get out if they've been in there a while. You might need an O-ring pick or some pliers or something like that to get it out of there. But it is regular size PTFE tube, so it can be replaced easily. So to replace mine, I'm just going to take a small piece of cap tube. You can use any PTFE tube you have. Just make sure it's somewhat flat on the end and pretty close to accurate. But I'm going to slide it in, and then I'm going to use a razor to cut it off at the end. But you don't want to cut it off flush. You want to leave just a little bit, probably around a millimeter or less, sticking out the end of the tube. So try to get it as flush as you can, and cut it right about there. And the reason why I'm telling you to leave just a little bit out is because when it's inside that heat block, it's actually going to mate right up with the other side of your nozzle like this. And when you leave just a little bit outside of those threads, it's going to compress when you tighten it down and actually form just a bit of a gasket. This will minimize the chance of any filament pooling inside that heat block and causing a jam. Kind of doing the same thing that we would do on a Creality hot end, if you're familiar with those. The ones that go, the PTFE goes all the way through the hot end down to the nozzle. Now for the heat block, the threads and everything on these are compatible with E3D items for the nozzle and for the barrel, but the block is just a little bit different shaped. It's not quite as tall, and it doesn't have that sandwich type on it. It's got these set screws, but you could probably swap in one of those if you wanted to. I'm going to try to use all the stuff that came on the printer as much as I can. So for the barrel, I'm just going to screw it down in here just a little ways. Then I'm going to put the nozzle on. I am going to use a new nozzle. This is a Creality style, but they'll work just fine on these Geeetech printers. I'm going to back that nozzle off the heat block about a millimeter, and then I'm going to tighten the barrel up against the nozzle. Now if you have this type of hot end, where you have the barrel and then maybe some nuts that made up here on the block and on the hot end side, on the heatsink side, there is kind of a procedure for doing this. So put your nozzle on, get it set at about that 1 millimeter, then put on your barrel. Then if you have these nuts that keep it locked in place, put that bottom one on now. like so. These do actually help keep it from leaking quite a bit. You can see how clean the top of this is. And these nuts are 10 millimeter. I'm going to go ahead and tighten this top one up now. Get it fairly tight. It is still aluminum, remember. And then after that one is tight, then tighten up your nozzle. The reason why we're doing this last is just in case that nut pulls the barrel up at all, we're still going to have the opportunity to snug the nozzle up so it'll be tight against that PTFE tube. Just make sure it's nice and tight for now, but we will need to come back and hot tighten that before we start using it. And on my setup, I do have this metal mounting bracket. It'll slide on here, but before that, I'm going to spin on another one of these nuts. Then I can slide my plate on. This hole here is to fix it on the extruder mount. And the extruder does have threads on it. There are no threads on this hole for the barrel, but there are some here. So we'll spin this on. And the whole hot end assembly will look just like this. I want the barrel flush with the top of this extruder motor mount. So I'm going to go ahead and put my mounting screw in to hold this plate on. That screw is in, and now that I know where everything's going to be located, I'm going to go ahead and tighten up this nut here up against the plate so nothing spins. A lot of printers are going to have a set screw or something that does the same thing, but this will keep it in place just by tightening that up. And there's the assembly all tightened up. It's not going to go anywhere. Now I'll go ahead and put my extruder motor in place right here. This is a great opportunity to clean off your filament gear if you need to. Just clean the teeth. Mine's actually pretty clean. It's just the finer tooth brass type. Then we have a short M3 screw up here to keep the plate in place. This has to be flush to enable the extruder arm to move freely. Our spring will set down on that mounting screw. It just helps to keep it in place a little bit. Now is also a great time to make sure that your idler is spinning freely. Then we have a bolt that sets on top of that spring that we can use to compress it if we need to add more tension. And then the idler arm will just set down over the mount, and we can tighten this screw. There is a collar inside here, kind of a bushing that allows this arm to move. Don't get crazy with tightening this one down. You want it to move nice and freely. And here comes the first upgrade we're going to make to this machine. And that is this very simple printed part right here. One of the biggest annoyances about this extruder setup is that it's hard to feed the filament in for the first time. You have to get from these gears to that hole right there in the barrel without the filament flexing, and you have to be pretty accurate, so that filament's got to be nice and straight. To help with that, and to help print flexibles if you want to, you can print out these guide parts, and they just slide in right here. They actually do float around in there a bit, but you'd be amazed how much just that little part helps you when feeding filament. Again, links to all these parts in the description. Then we can put our heat sink back on the front here, and our 40mm fan, and then install these two longer screws that go into the motor to hold everything together. I would hate to guess how many times I've had this very assembly, this very one, apart in my lifetime. And our extruder hot end assembly is now back together. Now we can focus on mounts and where our sensors and fans are going to go. So I'm going to go ahead and stick with this metal bracket that came on my printer to mount it on the X-axis. It just sets right here. And then you have a couple holes here in front for mounting other things. But I'm actually going to mount my part fan in the back. And I'll show you more about that in a second. But I'm just going to reattach this onto my metal plate with these two M4 screws. My plate's on. Now I can better tell how the Bltouch needs to mount, because it does need to be a certain height based on how long your barrel is and the length to the tip of the nozzle. So we'll have to figure that out. And how far the part fan needs to come down to be able to cool the plastic coming out the tip of the nozzle. That has to be a certain height as well. Depending on what barrel and what setup you have, this might be different. But hopefully the parts that we create are going to be really easy to edit, so you can make them longer or shorter if you need to for your setup. So for the Bltouch, I found this mount on Thingiverse by Wysocki. I know I probably butchered that name, but it is adjustable. So it'll just mount on these two holes here with some M3 screws, and we can adjust it up and down just in case you have a different length barrel or you need to make a height adjustment. The Bltouch is pretty particular how far away it is from the nozzle vertically. So I just mounted it on the bracket with some M3 by 16mm screws and a couple of nylock nuts. and then we can mount it on our housing. I'm going to use some M3x6s with a couple of washers on them. And I put the bracket on with some button head screws because they were easier to get in behind the Bltouch. You might have to do your final snug up with the sensor off, but I want to get this bracket so the end of the Bltouch is about 3 millimeters higher than the tip of the nozzle. We can adjust it after we get it on the printer, but that should be close to exactly where it needs to be. So the assembly is pretty much done. Now I'm going to go ahead and put it back on the printer, and we'll deal with the part cooling. And for part cooling, I found this duct right here. There are a couple of different versions of this. I found this on Thingiverse. It was created by YB Jack, but it's kind of a cut down version of that rail core fan duct that we were talking about at the beginning of this video. It does cool it from both sides, and it uses a 50-15 fan. And a tip, if you're going to print this, it's going to come out a lot better. You're going to have to use supports, but go ahead and print it at a 45-degree angle. That way you don't have to worry about bridging over these ducts where the air is going to go. That's going to make it a lot more efficient. You won't have to deal with strings or anything like that. And this duct is just made to set on this X carriage and sandwich in those two existing screws that actually hold this bearing on. So it fits on just like this. And then you can put those two screws back in. So our fan's on, and then the whole carriage can just mount on here. There's two M4 screws that come through the back. It'll just set on just like this. And that part duct is just barely above that nozzle, and that's exactly where you want it to be. Now as for the fan for the part cooling, you can set your fan on here. It's a pretty nice fit for most of these blower type fans. You can just set it on, and then you can glue it, and that will work, but I do think we need a bracket to tie it down to the carriage a little bit, just to make it a little sturdier. That shouldn't be too hard to make. For now, we can get by with it just setting on here with a couple of drops of glue. It does seem to be holding, but we don't want it moving around. So I'll go ahead and get a bracket created, and then I'll put an update out. Then we can go ahead and put our heater and thermistor back in. On this heat block, they're just held in with set screws. The heater does have two, one on the left and right. You might want to go ahead and put a little Kapton tape around the thermistor and the heater to keep them together. Just give them a little extra support. And I like to zip tie them together as well. Then we can go ahead and plug our extruder motor back in, and our hot end fan. We can plug in our Bltouch for now. I will show you how all this hooks up to the board before we get ready to test. So the next thing I want to tackle are the lead screws on this printer. That is definitely one of the biggest weaknesses that's always been plaguing this machine. It came with 8mm threaded rods, and you can see them if I just spin them by hand, how bent they actually are. So to deal with that, I printed out these two blue pieces you see. It detaches the nut from the rod and just lets it float, the whole X carriage float on top of these. There are some metal washers on top so it doesn't wear the plastic. But separating that motion from those rods did actually let it produce some fairly good prints, at least a lot less wobble on them. But that's just not a good solution all around. Now it's pretty easy to get things like this. This is an EMA 17 motor that has an integrated lead screw. This is a TR8x8 lead screw. It's 4 start. This is the most common lead screw you see on 3D printers, but you can get these on AliExpress for just a little bit over $15. And for the $30 and some change investment, they're definitely worth it. And I don't know if it's how they're manufactured, but most of the time, you never see these with a wobbly screw. They're always pretty straight. So that's going to be a huge improvement for this machine. On top of that, I do have these top Z-rod holders that have a bearing. I actually designed these myself, but this is probably a terrible idea. You don't really need to keep the top of that shaft. Since I do have the Z-wobble parts on there, this didn't hurt me too much because the screw was already so bent it really didn't matter. But with that integrated lead screw, it's going to be more than sturdy enough to support this carriage, and the top can just be free. So I'm going to remove these and replace them with a different part. This one, created by A.W. Doran on Thingiverse, this one doesn't even have a hole for the lead screw. It's just open so that it can do whatever it wants. This should be a lot more effective. You don't need to capture the top of that screw. So let's get these screws and motors out of here. We'll just take these holders off. It's just a couple screws here on top. They do go into the acrylic. They have a trapped nut underneath. Be careful if you're dealing with situations like this. I have broke this acrylic frame a couple of times. It's missing a few chunks. Then we could just remove the couplers on both sides here. And since the X carriage isn't actually tied down to anything, it's just floating here, we can go ahead and remove these smooth rods. And the whole X carriage is just going to be able to slide right off. And we can finally get rid of these threaded rods. We'll go ahead and remove the existing Z motors. Let's get this glass out of here. But we can just tilt the printer back a little bit and slide in our new integrated motor. And it fits right up just like the other one. It does use the same JST type connector like the old motors do. Be careful, there are some that have integrated wires that use a different type of plug. If you get those, just make sure those wires are long enough. But we can even use the same hardware to put it right back on. And while we're at it, I also printed out some of these dust caps. These are from the Prusa STL files. They just go down over the screw to keep dust from getting inside that motor. It's just a good idea. It'll just sit in there right like that. And our Z-screw upgrade is complete. This is going to be a huge benefit over what was on stock. But we need to talk about the X carriage just a little bit more. And that's about these X parts right here. On this printer, these are just folded sheet metal. Some of these have printed parts. The printed parts are actually a little bit better for a couple of reasons. But we're going to go with these. If you have these, just make sure that they're flat. Most of the time you see these right in this area where they're bent up or down because somebody's been messing with that Z-nut. So take these apart, make sure that these are flat before we continue on to install a Z-nut. It's also a good time to go ahead and grease your bearings here and check and make sure all the pulleys and everything are turning smoothly that support that belt. But check both sides. And since we mentioned the Z-nuts, let's go ahead and talk about which ones you might get in a printer kit like this or with those motors that you buy. Most of the time you're going to see this brass one. These do have a little bit of slop in them. You can buy kits that have a spring that separate two nuts to try to keep them loaded all the time, so you don't have slop in the nut when it's trying to do things like Z-lift or move around from place to place. But these are definitely not my favorite. These are a specific screw pattern as well, those 4 screws. And then you see Z-nuts like this. These are Delrin nuts. These are the ones that I actually like the best. You don't have to worry about slop like you do with a brass one. This takes care of it, and they're self-lubricating. But there's a couple different types of these. Not only for different style of lead screw, but these are what I like to call the Prusa style. They're a lot bigger bolt pattern than the brass ones that you're going to see. And the ones that came with this kit are the smaller bolt pattern. They're a lot more common than these. But they do make Delrin nuts in this bolt pattern, like these. And these are right around $1.25 a piece. So they're not very expensive, and they're definitely worth the upgrade if you can get a hold of some. So definitely use these over the brass ones, and you're going to be a lot happier. But these will go right on the printer. So back to assembling our X carriage and getting everything put back together. So I've got the X carriage back together, and just note on this machine how this works. Their intention was to isolate this side of the X carriage. They have these collars that keep it from moving on the smooth rod. The motor over here has no way to tension the belt. They wanted you to tension it by putting this side of the X carriage in place on the smooth rod and then pulling against it with the belt with this wing nut over here. That is not the best way to do things. You're going to end up pulling in on your Z and smooth rods here, and that can cause things to bind. So if you have this design, we should really rework it. But if you have one of these, make sure you don't over tighten that belt, because that's going to cause a lot of different problems. But now we're ready to go ahead and put on our new Delrin Z-nuts. I'm just using 2 M3 by 8mm screws to hold that nut on. If you want to put all 4 in, you can, but 2 should be more than sufficient. Now I'm ready to go ahead and put this whole X carriage back on. I'm going to go ahead and remove my fan duct just so it doesn't get in the way. We'll just start with the new lead screws. We'll spin them on the new nuts. We'll move those down. We can go ahead and slide our smooth rods back in. And then we can put our new Z-tops back on. And our new Z-tops are on. We can go ahead and reconnect the part fan now that the X gantry is in place. And there we go. Our hardware updates, at least for this video, are now complete. We just did a couple of quick things. BL touch mount, part cooling fan, Z-tops, and integrated Z lead screw motors. Just with these few changes, I know it's going to improve print quality greatly. So we really didn't make a whole lot of hardware changes here, but I do think this is the right way to go. Plus, we don't want to make a whole lot of changes all at the same time, because then we really won't know what improved our print quality. But there's one more thing we need to address in this video, and that is the wire management. It is a complete mess. Just take a look at it. By default, Geeetech gives you two holes they want you to route the wires through. This one up top, and this one kind of in the middle. These are intended for the bed wires, everything else goes in here. And that's just not a good way to route your wires through an acrylic frame. It does have sharp corners. Also note all of the different looms that have extra wire just zip tied together. This is what happens when you don't have proper connectors to make your own wires. Now for a new user, this kind of thing is pretty common. You're not going to have all the different type of JST connectors and ferrules to make this work. But on a revisit video like this, we definitely need to give this some attention to make sure everything is in working order. So I'm going to go through and shorten up a lot of these wires, put new connectors on them, and just make everything look a lot nicer in general. In this process, I'm going to go ahead and get rid of my filament sensor housing. We might visit this in a later edition of this series, but not now. That just complicates things as far as wiring goes and configuration. And our part cooling fan was a 4040. I have it soldered in. We need to change it over to our new fan. So we're starting to make some progress, but before I go too much further, I wanted to talk about the Bltouch and how it's wired on a GT2560 like this. Your black and white wires for the end stop, they will go on your Z-min pin. That's these pins right here. And the white wire will go on the outside pin, the outside of the board, just like that. And on the Revision A boards, they actually have a spot for the servo. Not all GT2560 boards have these pins, but they're right down here underneath the thermistors. You can kind of see them right there. The outside pin will be the brown wire. From the outside in, it'll go brown, red, orange. And for now, I'm going to leave that good on the wire management. Things are out of the way. A lot of the connectors have been replaced. I think we need a case around the board, so I'm going to leave a little length just in case I need some more, depending on the case we use. But that will be in future videos. We should be good for now. I will also leave some links in the description about the different types of connectors I used on this and the ones you might run into for your 3D printer. Now we're almost ready to do a test print, but we're going to have to cable up USB and make some changes to the firmware because we have changed the lead screws. We were running a threaded 8mm rod before, now we have TR 8x8s. So the Z steps are going to be a lot lower. We've also made changes to the location of our Bltouch probe, so we'll have to change up the offsets. Even if we have to compensate with the bed knobs for now, we can still do a test print. We're not going to tackle firmware until the next video. We can clean all that up then. So the printer's powered on. Let's go ahead and connect up. When it boots, it spills out a lot of different values. The one we're after first right here, M92. Our Z is currently set to 2560. This thing is set to 16 times microstepping. That's done with the jumpers on this board. And note what happens on this printer if we try to run an M500. M500 is saved to EEPROM. EEPROM has been disabled on this machine. I did that a lot in the past because sometimes values can get stuck in EEPROM and be kind of confusing. So we can't save our changes yet without altering the firmware, but we can run prints as long as we don't power it off with different settings. So all I'm going to do for now is M92 Z400 because 400 should be the correct setting for TR 8x8 lead screws. M503, that change has been made. So we should be good there. Again, we'll clean all this up when we do the firmware update. Now I've turned software end stops off with M211S0 so I can move without homing. And I want to try to move the Z motors, and they don't move at all. And that's probably because our new motors aren't wired the same as our old motors. So we have to troubleshoot that. But that's kind of a good thing because I can show you how to do it. So the first thing that I'm going to do is make sure the wires that I'm getting ready to test this motor with are wired the same way as the ones on the printer. and they are. Sometimes these can be cross, depending on the motor that you're using. And more than likely, that's the exact issue that we have right now. We need to cross the wires when they're not. But these are the same as the ones on the printer. So now we can proceed with testing this motor just to see how it's wired. We'll cable up. And the easiest way to figure out what two coils go together is to just jump the wires. So let's just start with black and green. With this little jumper. Now the motor is hard to turn. So those two go together. If it was easy to turn, we'll just shift it to the pin next to it, like this. Those two don't go together. So more than likely, black and green go. Go ahead and test blue and red. It's hard to turn again. Those two go together. So this wire is wired correctly to use this motor. Now we need to check the one on the printer. Here's our Z motor cable for this side. Z motor is really easy to turn. Remember, this cable is exactly the same as the one we tested with. Let's hook up blue and red. Motor is still real easy to turn. That's what we expected. Let's just move this one over to the green wire. Now the motor is hard to turn. So the coil pairs are different on these motors than our original motors. And that's the easy way to tell. So to fix it, all we need to do is flip red and green. That way the red and green coil will be mated up and the red and black coil will be mated up. And that'll fix the problem. So we'll do that on both of our Z motors. I just use an O-ring pick to push down the pins lightly. Then you can slide them out. We used to have blue, red, green, black. Now we're going to do blue, green, red, black. And that should fix our issue. We'll go ahead and do it to the other motor plug. But let's go ahead and test one more time just to be sure. Now we have our black and red together. Motor's hard to turn. Green and blue together. Motor's hard to turn. So there we go. After I switch the other one, we should be fixed. Just a minor delay. We can now go back to testing. I do have to reset my EEPROM one more time. M92 Z400. Again, we'll turn off software in-stop so we can move around freely. M211 S0. And hopefully now our Z motors will move. And they do. Probably need to level up that gantry just a bit. But now let's go ahead and auto home. We did home successfully. We are not in the center of the bed because of our probe offset. But again, we can probably get by for now because we're not tweaking the firmware quite yet. I'm not sure if we could get by with a G29, do an auto level, but let's go ahead and try. I'll just enter G29, let's see what happens. Looks like we're going to be skewed a little bit to the left, but it should still work for our purposes. We just want to have a test print to test some of the things that we've changed. Okay, so I'm pretty much satisfied with the modifications we've made. We were able to home, we were even able to auto level. We have a lot more modifications to go, so I'm not going to go about tweaking things exactly perfect yet. If I need to adjust the first layer, I'll just adjust the knobs. I just want to test out these mods. We'll make things a lot more permanent when we get all the firmware redone. So let's heat up, get some filament, and try that G-code out. And before we start testing, I went ahead and set the hot end to 240 because I want to hot tighten that nozzle real quick. There, that should be good. Now we should be ready for some movement. And here it is. Now, it's not perfect. You saw it took me quite a few times to get that first layer done. I attempted it about 4 or 5 times before I actually got it to stick, got the first layer height where I wanted it. But we made a lot of improvement. We do have a bit of stringing. I know I'll probably have to dial in the extruder. That will all come when we start tweaking the firmware. But this is a huge change from our last benchy. If you want to compare those side by side, it's not even close. So far, so good. I'm happy with the path that we're on. And it's only going to get better. So the first round of upgrades is done, and the print quality has drastically improved. But we're nowhere near done yet. We still have a lot of tweaking to do. We're going to tackle the firmware in the next video, and maybe some of the safety concerns that I have around this machine. But I think we're well on our way to getting this machine printing better than it ever has before. Hopefully you liked this video, and I'll see you real soon on the next one.